Okay, so this is LT2, which is finding the relationships between arc length, radius, and radian measure. And so arc length, it can also be labeled as S, and it's the portion of the circumference of the circle described by an arc measured in units of length. So if we look at a circle, we can kind of think then that this part can be an arc length. You can have this be an arc length, or you can have the entire circumference of the circle be an arc length. Radius, which we label as R, is just the constant distance from a fixed point, which is our center of a circle. And we all know our radius. It's going to be the same from to whichever point on the outside of the circle. And then our radian measure, like it says, it's going to be labeled as theta. And radian measure is just a different way of labeling an angle measurement. We're used to seeing it labeled in degrees, but 1 radian is the measurement of an arc, or the measure of the central angle. So like we said, the measurement of an angle. And when you have 1 radian, it's going to be, the arc length is going to be the same as the radius, and we'll see more of that in a couple slides. So it says radian measure, so theta is equal to arc length, that's going to be our S, over radius, so R. And that's shown over here in the picture. We can see that they give us our radius, and our radius would be the same up here, and this would be our side length here. So like they were saying, how if we have a radian measure of 1, so 1 radian then is going to be equal to our S over R, and to get 1, our S would have to equal R, so that's how they get those lines drawn up there showing that S and R would have to be congruent. And if we just kind of think about it, if we think about theta, and they give us an arc length of 5 centimeters and a radius of 2 centimeters, well, those centimeters are going to cancel out. We're going to be left with a theta equal to 5/2 radians. So then, if we think about it being the circumference of a circle, the formula for finding the circumference is going to be 2 times pi times the radius. And so if we plug that in for our arc length, we're saying our arc length is the entire outside of the circle. So we'll say 2 pi r, and then our radius is going to be r. Well, those r's are going to cancel out, and this is going to be 2 pi. And since this is our formula for radians, we're going to label this as radians. It can be abbreviated to just rad if you would like. And that's shown down here in the purple. You can see that when you're doing the whole circle, its measurement is going to be 2 pi radians. If we think about half of a circle, so what they're showing in the orange, half of your circumference is just going to be 2 pi r divided by 2, which is going to leave you with pi r. So then if you plug that into the formula, you get, not the 2, you're going to get pi r all over r. R's are going to cancel out again, and you're going to get, like what they have, pi radians. So what I want you to do for before class is try these 3 problems. And I think it's easiest if you sometimes label as you're going through. So if you notice you have an arc length, you can label that as S equals. You notice you have a radius, you can label that as R equals. And if you have a radian measurement, you can label that as theta equals.